sklearn kernel approximation skewed Chi2 sampler. Description: skewed Chi2 sampler is a kernel approximation method in scikit-learn that approximates the feature map of a chi-squared kernel. This method is particularly effective for high-dimensional sparse data, common in text and image data. The chi-squared kernel is a popular choice for such data as it captures the similarity between features based on their occurrences. Inputs: X. This is the input data, typically a sparse matrix representing features, with each row corresponding to a data point and each column to a feature. N components. This parameter specifies the number of components in the approximate feature map. It controls the dimensionality of the transformed data. Higher values generally lead to better accuracy but also increase computational cost. Outputs: X new. This is the transformed data, which represents the approximated feature map for the input data. Each row in X new represents the transformed feature vector for the corresponding row in the original input data X. Steps: Feature extraction. The skewed Chi2 sampler extracts a set of features from the input data X, which are used to approximate the feature map of the chi-squared kernel. Feature transformation. The extracted features are then transformed using a specific mathematical function, which approximates the chi-squared kernel function. Metrics: Accuracy. This measures how well the approximated feature map captures the similarity between data points compared to the actual chi-squared kernel. Computational cost. This measures the time and memory resources required to perform a transformation. Visualization plots: Scatter plot. This visualizes the transformed data points in a 2D or 3D space, which allows for visual inspection of the data distribution and the effectiveness of a approximation. Fine-tune parameters: N components. This parameter directly controls the dimensionality of the transformed data. Increasing N components generally improves accuracy but also increases computational cost. Uncertainty methods: Ensemble methods using multiple skewed Chi2 samplers with different random seeds can help estimate the uncertainty in the approximation. Challenges and fixes: Challenge 1: Overfitting. If N components is too high, the model might overfit to the training data, leading to poor performance on unseen data. Sample use case that resulted in challenge 1: using a high N components value for a dataset with a small number of training samples might lead to overfitting. Fixes to challenge 1: Consider reducing N components or using techniques like cross-validation to avoid overfitting. Challenge 2: Computational cost. For very high-dimensional datasets, the transformation process can be computationally expensive, especially with large N components. Sample use case that resulted in challenge 2: Applying skewed Chi2 sampler to a large dataset with millions of features and a high N components value could result in significant computational overhead. Fixes to challenge 2: Consider using a smaller N components value or exploring alternative kernel approximation methods with lower computational cost.